Georg Greve, who's the co-founder and CEO of Verein AG, who's going to talk to us about applying authenticity to Swiss healthcare. Please welcome him.
Thank you. So, I have been in this community for a very long time. In fact, I've been a GNU project contributor since 1995, and I've been doing quite a few things on the internet policy side as well as the free software and open source side. Started the Free Software Foundation Europe and had a spin-out from the German Federal Office for IT Security, and today I'm here again at FOSSASIA to tell you about what we've been working on for the last years, and I'm actually quite excited about that because it's about 2 weeks now that I can actually really talk in public about this. So, applying authenticity for Swiss healthcare. Quickly, who are we? The team, the merry band with whom I'm embarking on this journey is a team of, meanwhile, 16 plus people. We keep growing. You see some of them here, at least some faces to put to the team actually. We founded the company 2017 in Zug in Switzerland because that's where I live these days. And we've built this into one of the leading teams for SSI, or self-sovereign identity. Among other things, we actually did contribute the stack of SSI that you find in the Eclipse Foundation. My team built that initially, and we've done a couple of other things that I'm going to be talking about, but I really want to focus on what we're doing now in order to address some of the biggest challenges that we have in terms of privacy, security, control, which are all the topics, centralization, which are all the topics that ultimately affect all of us very much right now, and Swiss healthcare finds itself in the center of all of this. Before I can tell you about the approach to the solution, though, I need to say 1 or 2 words about the analysis of the problem that is underneath all of this. So I have to actually say a few words about the web itself. Now, the web is awesome, right? We all love the web. And in fact, I still remember how we were all really hopeful and positive and thought open knowledge sharing would solve all problems of the world, right? We thought people would be perfectly informed, they would make fantastic decisions, democracy would work so much better now that we have all the information, and nobody would ever make a stupid election ever again. Boy, have we been wrong. I mean, I was just as wrong as everyone else, right? I wasn't the smart guy in the room back then who said, oh, this is not going to work. I thought this too, right? But the open web that we collectively dreamt of has not really proven to be what we were hoping it would be. Let's put it diplomatically. And I mean, it was at its time an incredibly important invention, right? Don't get me wrong, it made a lot of things possible, and it was a huge step forward from where we were. But also, I don't think that it's the end of all means. In fact, I don't think it's the end of the evolution. And ultimately, there is this architectural principle that form follows function, and that is true for technology architectures as well. Remember this guy? I think he's been at FOSSASIA a couple of times as well. He's always been talking about how in the early days, computers had no user accounts, no logins, no passwords, right? And that's how it should be. That's how it was supposed to be. All that security stuff is really annoying and just gets in the way. The initial conception of the web follows very much the same basic idea of openness, sharing. The focus was on making it work, and we were so excited that we made it work. It was fantastic. Finally, it worked. But again, that concept of no computer should ever be secured against outside intrusion didn't really stand the test of time. So what I'm trying to say is architecture matters, and retrofitting security onto existing systems built for something else has limits. You cannot easily turn a car into a rocket, right? If you want to have a rocket, you build a rocket, not a car. And there's consequences, and sometimes unintended consequences, to the technical, architectural choices we make. When we realized the open web must have security, we tried to build security for it. And the best approach we found were trust service providers. So places that would issue certificates that we could use to encrypt things. And they now issued basically certificates that had identity, organizational or personal, attached to them in terms of trying to secure the traffic, right? TLS, later also we realized, well, we also need to secure DNS because it's another vulnerability of the system. And so we kept applying layer after layer after layer to this. But the security need drove centralization, right? The TSPs ultimately became the bottleneck, the choke point for the web, until we got so upset by the rent seeking that we said we need to fix this. And so a bunch of companies came together and they said, let's encrypt. And suddenly with Let's Encrypt, now everybody has certificates, but they're all from Let's Encrypt. So now Let's Encrypt is de facto today the single point of failure for all security on the internet, because they issue like 60% of the certificates. If they ever get compromised, and I'm not saying that they're doing a bad job, don't get me wrong. It was good that they exist, they were necessary. But again, it's a single point of failure, right? And architecturally, that should worry us. That is not a healthy design that if one organization gets compromised, the entire internet fails. That's not great. It also has unintended consequences. The entire web architecture, I'm going to say 1-2 words about that in a moment, actually gravitates towards a platform and the surveillance industry. It's like a built-in slippery slope. If we ran the same experiment 100 times, we would arrive at the same point 100 times. Because when you take the architecture of the web as a federated approach, and you combine that with economies of scale and networking effects, you have a tendency to centralize. Things gravitate towards certain points. And the impact, I'm pretty sure I don't have to explain to anyone. I think we all, in this room at least, are fully aware of that. It's easy to think, right, that is a natural effect, that, you know, no matter how we have done it, you know, there is no alternative to it. But actually, it's not true. This is a system-inherent architectural decision that we made, right? Kind of like if you want to build a house on that slope, you know, you need to make a slope that your house is straight, otherwise everything falls off the table. But if we leave the lower slope away, suddenly, you know, the architectural picture looks very, very, very different. In fact, what we've done right now, because people are so focused on the web, they can't even conceive of solutions outside the web anymore, right? They cannot think of a world without web, or they don't even ask the question, is the web the right answer to this architecture that I'm building right now? So we add layer on layer on layer, right? But more layers create more problems. Yet we keep adding layers. That is unfortunately what is happening right now. And we do that including for some of the most personal data we have. Can anybody tell me whose health records that might be behind that URL? Exactly, right? Doesn't take a genius. Yet it demonstrates exactly the problem. In a federated web approach, the URL always contains the identity of the party on the other side in the DNS name in some shape or form. Of course, I can turn on DNSSEC, I can do all sorts of stuff, but the web design, the architecture of the federated web forces me to decide between either control, right, my own domain, I control everything, or privacy. Nobody can tell who this is, because yes, I could try to get some form of sworn privacy by going to Google, right? Then it's a Google address somehow, a Google URL, and at that point in time, nobody knows who's behind it, but of course, Google knows everything about me. So I have zero privacy and zero control, but some privacy to the outside world in terms of anyone who's not Google doesn't know who's behind this. And this is a system-inherent architectural thing, right? We built it into the system because back then we had other problems and we didn't know any better. What I'm saying is we should actually consider whether there isn't a better approach. I was at the DICE conference last week, and one of the speakers said something very insightful, which is that paper is peer-to-peer. That is the reason it is so entrenched and so hard to replace in certain domains, because two people can exchange a piece of paper without an intermediary. There is no one in the middle, right? That's why, for instance, in trade, paper is still dominant. It is peer-to-peer, and we got to realize that that is a value that paper provides that most digital systems today do not. Right? People are trying to push the trade onto platforms, but the companies in the trade ecosystem are smart enough to realize that once they are in the platform, they're fully dependent on the platform, and they don't want that. Because they know there's going to be rent-seeking, they know they're going to be squeezed. So paper persists for that reason. So I think we should actually conceptually build systems that are more like paper in that regard. We want systems that have a primitive layer underneath that is built on security, privacy, authenticity, right? Basically cryptography underneath the systems we built, the architectures we built. And this, it's not my like big idea insofar as others have had that idea as well, right? That's the whole premise behind SSI. And of course, I'm not the only one that has these ideas, right? Gaia-X actually, we were involved in that to some extent, had this very same idea, right? It said, we can't just rebuild what is there because that's not a race we can win, right? Don't enter a race that's already decided. There's no point to appear at the starting line an hour after the whole race is finished. So there was this idea that we could build something better in terms of, granular data sharing, something that actually would make it possible to connect in a way between ecosystems so that the ecosystems would keep control, would do all these kind of things. So there's been that idea, and that idea I thought was pretty good. It was a pretty interesting idea. There was a lot of people who criticized it because they didn't understand the idea, right? They thought, oh, they're just going to build a data center and a web thing and whatever, and that's it, right? But they were just expecting to see old architecture. They did not understand why people would try to build a new one. And in the end, they can feel like they were right because it all failed, but it failed for different reasons, right? The reasons why Gaia-X failed, and I think by this point in time we can say that, has more to do with death by committee, too many lobbyists, too much technology policy in there, and even some corruption. It's been a very interesting tale. But it did allow us to understand some principles. There is some code and some systemic understanding, including in industry, that came out of this, which is very useful. And I do know that SSI is not widely known in the open source community yet, which I think is a mistake. So let me quickly try to do the minimum introduction layer here. SSI, self-sovereign identity, is the word, the term under which it is most well known. Personally, I really do not like that term for the simple reason that I think it's distracting from the actual value behind it. When you think about SSI, the moment where it made click for me was when I understood that it is actually a peer-to-peer, decentralized, self-verifying PKI infrastructure that allows me to build architectures on top, right? The value is not in the identity. You can use it for identity. You can also use it for EID systems and stuff like this. It has the right properties for those use cases. But the actual value of this is much, much deeper and much wider. So the self, actually, it's built for interactions, for creating the for solving the key management problem in a peer-to-peer fashion. The sovereign is really about control and privacy, right? We want control and privacy over our own data. And identity is actually, we're talking about data and applications across the entire board. So SSI is actually a horrible term for this because people focus on the identity bit and completely get sidetracked, right? The architecture by which it works, basically you have three roles, right? You have the holder, that holds credentials, you have the issuer that issues them, and the verifier that verifies them. It doesn't seem super different from what we're doing in the web, insofar as, you still have someone who issues credentials and so on. But in this case, the verifier, so the party to which you want to authenticate, does not need to connect to the issuer at the time they check the certificate. And you do not need the issuer at the time that you want to present a certificate. Which means the holder, which is you or your device or an organization, right? Anyone and anything can be a holder in this mental model, holds the certificate and can use it with whomever they choose. And that party, the verifier, can verify that certificate to whichever level they need to without needing to directly contact the issuer at the time. Usually there's underneath some layer of a trust ecosystem which can be in different systems, that can be ledgers, it can be trust infrastructures, it can be lists of certificates, it can be all sorts of things, but you need some kind of anchor against which you can check it. But there's multiple designs for that allow you to be privacy friendly and actually make sure that there is no phone home built into the system, right? So suddenly, when you do it this way, Google is no longer at the table when you do something online. And, this is how it looks like, right? So whose records are those, right? You create a decentralized identifier, a DID, which is a W3C standard, for every interaction if you want to. There is no way to correlate them at all. That is built into the system. It's one of the design properties of the architecture underneath this. And that is a huge benefit. So this is actually a DID SVDX. This is I sent the identifier that we built for the Swiss healthcare system because we needed an identifier that actually did not base itself on the web for the very same reason that you saw in the beginning of the presentation. It serves W3C DID documents, but it uses IPFS to do so. So it is content-based addressing, so it's the hash of the document that identifies the document at the end of the day. And there's no way to link the hash to the document itself otherwise, or to know who issued that document, right? At that layer, all you care about is that the key on the one side and the key on the other side are from the same entity that you spoke to before. Who that entity is, you do not care about at that point in time. You then, when you have a secure connection peer-to-peer with them, at that point in time, you can then add trust gradually on the connection through exchanging verifiable presentations, which is how verifiable credentials are being shared between parties. So it is truly decentralized key management. It meets the paper test, actually. And it's very easy to use thanks to the fact that you have even IPFS gateways on the classic web, which allows you to use this in a web stack very quickly and easily, which is one of the things we wanted for it. The first application we built on this that's going productive this month, actually, is Seal, which is a data exchange application applied, in this case, to email, but you can use it for any kind of data type. And it uses a cryptographic container that is shared in a sharded way over IPFS as well, and moves all the data and control to the edge. I don't have enough time to explain exactly how it works. Anyone who's interested, hit me up afterward. I would love to tell you how it works. But basically, the idea behind this is to create an application that already moves all the data to the edge, that still feels in the same way that the users know, right? It still meets the what do I as a user know test, right? This is, for them it feels very familiar, but all the data is only ever at the edge. Once that object is created by the Seal engine and sharded and encrypted and everything, right? At that point in time, even the sender has no more access to the data, right? Unless you keep a copy deliberately, which, you know, in this case, we don't. Only the recipient has the first shard plus key in order to assemble the whole crypto container and actually decrypt it on the edge again. What this does for us is it gives us an upgrade path towards a decentralized world where we have agents and wallets and can move this whole thing towards a native peer-to-peer connection pattern where, in fact, instead of sending these containers over classical ways and people opening the application on their phones, which actually is pulled out of IPFS as well, ideally, you can actually then start moving this towards applications on the devices that use the hardware security properties on the devices to directly communicate with one another. And there's an upgrade path that for the doctors means they do not need to change what they do today, right? Because doctors are not the most technology-happy audience. They don't want to touch technical systems typically. They don't want to change how they work. And users are also not always very happy to change the way things work, so we needed a path to lead them from where they are today to where we want to go with them. But this already contains the verifiable presentations, because what we are actually working toward, and this is the goal, I mean, it's a journey on which we are, right? We're now like 1.5 years into that journey. We expect that journey to take another 4 to 5 years, is the full sovereign data exchange idea, which means you have a data exchange peer-to-peer for any kind of data where you know with certainty who's on the other side to the level that you need to know it, right? Because you want to share, for instance, patient data, which is our use case here, but it's applicable to quite a few other use cases as well. Whenever you want to share data and be sure it reaches the right point, right? This is what we're building this for. It gives you authenticity, security, and privacy. It gives the user control over their own data, and it has the level of mutual verification in terms of who am I talking to as an institution on that side versus where does that information go on both sides. And of course, we want to integrate that into the Swiss eID, which is also built toward a SSI, so decentralized key management architecture. So there's a whole lot of things happening right now in Switzerland that are really quite interesting and exciting. Because the perspective here is that potentially, you know, Swiss CERN was the birthplace of the open web, which is wonderful. But now Swiss healthcare might actually become the birthplace for a new privacy and security as first citizens, as architectural underlying principles kind of system. And that's what we're building right now. And the best part of it is the Swiss healthcare system is happy for us to release all of this as open source, 100%. So we are very interested in people who are interested in this kind of technology, helping us build this, starting to build this community. And we, encourage you to come to us. Like, let's talk about how we can work together on this, because there's a lot more in this than just Swiss healthcare. Thank you.
Thank you very much. By a strange coincidence, I'm on a similar system myself at the moment for a completely different application. I have further to discuss. Stand in just the right place for the microphone to work. Before we get into Q&A, is our next speaker, Dinesh. Are you in the room? Can you please talk to these gentlemen about your slides? Thank you. We've got about 6 minutes before Dinesh is on, and I'm happy to occupy that with Q&A. Any questions? Stunned silence. Excellent. Then I have one. You mentioned there's more than one way of doing this, but you were talking about IPFS as the means of exchange of at least authenticators.
Yeah.
Can you give a sense of, if someone wants to build an application, what pieces have to be deployed?
Yes.
It's like you prepared for this question.
Yeah, shocking, huh? So basically, IPFS is a pretty interesting technology. If you haven't looked into it, I suggest you do, purely for intellectual purposes, because it changes your architectural mind. Content-based addressing is a magical thing in some ways. Not for everything, of course, right? But for some things it is, because once you change something, its address changes, right? Which means you have a built-in protection against tampering. You are sure that the data you push in somewhere in the system is the same data that comes out on the other end, because it's addressed by hash. If the hash were different because the data had been modified, you would not get the same object anymore, right? So that's why content-based addressing reduces the challenge of exchanging data to exchanging the hash, basically. Of course, you wouldn't just want to put any kind of data in there for, without any kind of idea of who pulls it out where and when, so you want to do some security steps on top. But principally, IPFS has some very interesting properties in this way, and the fact that it's a libp2p based swarm allows for distribution of IPFS across the world in a very, very good way. And the speed, by the way, my experience is quite good. We've been using IPFS now for several years to build actually other systems as well. And where it is a good choice, it's a really interesting choice, because it gives you new opportunity. You do want to run your own IPFS node, or ideally cluster, though, if you want to run this for production. That is one thing you want to have, because IPFS guarantees the integrity of the data. It does not guarantee the availability, right? It's not like it's a free hosting offer. You can just dump everything in there and it's going to be there forever. That's not how it works. You have a concept called pinning, which means this node will keep a copy of that data, and it will not delete it. Otherwise, you have garbage collection, and it can get garbage collected within 24 hours very quickly. And then it's gone forever, right? So if you want data to persist, you should make sure that you pin it. There is pinning providers on the web, actually, that you can use, which is one option. But personally, I would always suggest, if you want to build a production system on this, run a production IPFS for it, because then you have your nodes storing your data, serving them to the IPFS network, and you know the data is there when you need it. The way that Seal does it right now is, basically because it's integrated to the mail flow, right? The mail server sends it to the Seal engine. The Seal engine encrypts it, right? Generates a one-time key for it. then zips it, encrypts it. It does that redundancy for a mail with its attachments. So for every single MIME part, it does that once, right? So it creates lots of shards for it. Every single shard goes into IPFS, but only one part of it. So you never have complete crypted objects in IPFS even, because one shard gets transmitted directly to the recipient. And that is why only the recipient ever has all the shards that are necessary to reassemble the crypto container. So the beauty of this is you no longer have a size limit in terms of transmission, because you actually can transmit almost unlimited size data objects in a secure way using IPFS, which then creates a swarm distribution pattern which is resistant against surveillance and DDoS and all sorts of nice stuff. So we actually have a security base built into the distribution system even from the perspective of the user, which is quite nice.
Okay, that makes concrete in my mind what needs to happen for it to work. Okay, hopefully, well, we have a little more time. Any other questions? Oh, yes, hang on. But briefly, please. We theoretically have 1 minute, maybe 2.
Sorry, maybe we can keep it quick. But so just from my understanding then, the IPFS part, if you would replace that with just web storage, the difference is the content addressing, or?
Yes, and so web storage itself does not have integrity guarantee. The other part of it is that I can pull data out of IPFS in the node of my choosing, right? I, as the user, can pull from any IPFS node, and it will service me that data. Whereas in a web approach, only the web service provider will have the control over this, and they will see every single access. But there is use cases where you do not want to be in control of every single access. So this actually allows you to also address privacy concerns in terms of when the user opens those objects, when they want to pull the data, who actually can control that in terms of, do they see every single access, yes or no?
Okay, I think we have now solved the technical problems for the next speaker. So thank you, Georg. And can we please... Right.